Good morning, good afternoon, good evening, wherever you are. Thanks so much for joining us today. We're going to talk about best practices for architecting for data residency on AWS Outpost. I'm John Mallory. I'm on the Outpost business development team. Been with AWS several years across multiple roles, but really was intrigued by what capabilities Outpost offered. And so joined the Outpost team about a year ago. And I'll turn it over to my colleague David to introduce himself.
Hi, I'm David Filiatro. I'm with AWS Professional Services as a principal consultant, and I specialize in Outposts and security. Back to you, John.
Okay, great. Thanks, David. So what we'd like to cover today is to talk about how we actually define data residency, walk through a couple scenarios where customers have used Outpost to solve for data residency challenges, give you some information about Outpost capabilities and how you can apply them to data residency solutions and what kind of problems you can solve. And then David's going to do a deeper dive into specific controls and methods that you can use to ensure that your data stays on Outpost where you want it, and then audit that this is actually the case. So with that, we're going to go ahead and dive in. So I'd like to start off by making a subtle but important distinction here between data residency and data sovereignty. When we talk about data residency, we're really talking about the geography of where the data is going to live and where it's going to be processed. And so essentially when we talk about data residency requirements, we're talking about the requirement that all customer content be processed and stored in IT systems that remain within a specific location. And that location can be a country, a state, or even a physical data center, depending on the customer's regulatory requirements, their contractual obligations, and their corporate policies. Data sovereignty, on the other hand, is more restrictive and really goes into the policies that control and govern who can and cannot have legal access to the data and its usage. So really, they go part and parcel together. But most of what we're going to talk about today, we're going to refer to as residency. But AWS Outpost, at the end of the day, can really help you meet both data residency and sovereignty needs. So before I dive into Outpost, though, I'd really just like to differentiate a couple of things. I mean, first off is our first mantra with Outpost is generally, if you can use an AWS region, you should try to use that region if at all possible. It's going to give you more flexibility, more scalability, and essentially elastic on-demand characteristics in the fullest range of services. Countless number of customers, including FINRA, ZocDocs, and Vodafone, to name a couple of very stringent customers who are running their most sensitive workloads on AWS, who have made that determination that they can meet all of their security and data sovereignty requirements by running their entire stack in an AWS region, and that it meets all of their needs. Because essentially we have a lot of infrastructure and services in AWS regions to essentially make it easy to meet your security requirements, including the most stringent global security and compliance controls, the ability to scale to almost infinite scale with superior visibility and controls, the highest standards for data security and privacy. And since a lot of security exposures come through inadvertent mistakes and manual control, a lot of tooling to really automate and reduce risk with deeply integrated services and a lot of tools to monitor and inspect security posture automatically, as well as a huge ecosystem of security partners and solutions. And within those highest standards for privacy and data security, you choose an AWS region, and AWS will not move or replicate that data out of that region unless you choose to do so. Encryption is foundational. So we have encryption at scale, either with AWS key management service, or you can bring your own encryption keys using Cloud HSM. We do comply in the regions we operate in with all local data privacy laws by controlling who can access the content, its life cycle, and its disposal. And finally, as I mentioned, a huge array of tools and services that allow you to build compliant infrastructure on AWS. So, it sounds like I've maybe disqualified Outpost at the outset, but that being said, there are scenarios where you may not be able to move your data to an AWS region. And these can come under areas where you might need to do local processing. So you've got huge volumes of data to process at the edge, or maybe corporate policies that say you have to process the data, where it originates, where it's being created. Or we may not have a local AWS region, and it may be operating within boundaries that you do have policies, or there are governmental policies where the data and the processing do need to stay in that geography, or you may have very low latency requirements where you can't afford to haul the data back and forth between on-premises environments like large databases, high-performance equipment, or even mainframe computers where you need low latency connections. So if you do fall into any of these camps, you have data residency and data sovereignty regions, you can't leverage an AWS region, then you've come to the right place. Outpost could help meet your needs, and that's what we're going to dive in and talk about now. So essentially, one of the things we found with Outpost, and really what informed AWS developing Outpost, is that we found that customers want the same experience across on-premises and the cloud. So for example, if you are a global company where in some places you operate where we have AWS regions, that meets all of your needs, but then you're operating in countries or states or localities where we don't have an AWS region, you need to start to think about how to deploy in local data centers or colo facilities in those regions. The ideal state is that you're going to use the same solution stack in the AWS region and in these local areas where you're going to deploy to meet your locality and sovereignty needs. And so really that's what Outpost does. Outpost is the same AWS developed infrastructure as in AWS data centers, built on a foundational system called Nitro, which has very strong security capabilities and implications that David's going to go into more detail on. It's a fully managed service as well, fully managed, monitored, and operated by AWS as if it was in an AWS region. So that also has a lot of security implications, as well as leveraging a lot of the same security mechanisms that you'd use in an AWS region. And ultimately, what you get is a single pane of management in the AWS region, providing the same APIs and tools as in AWS regions, even if Outpost is deployed in your data center in a country where we don't have AWS regions. And so part of this is really running AWS services locally on Outpost, which obviously when you start to think about data processing, building applications that are going to keep processing data within a region become very important. So it ranges from core elemental services like EC2 for compute, EBS, elastic block storage for high performance block storage, but then also managed services like our managed database service, RDS, our managed analytics service, Elastic MapReduce, EMR, and our managed container services, ECS and EKS. So all of these run locally on Outpost, which really means you can take applications and deploy them to Outpost or deploy them in a region. So the way Outpost is delivered is as a fully packaged rack. It's essentially an industry standard 42U rack that you're going to install in your data center, or if you don't have data centers where you need to store and process data, in a colo provider that exists in that location. It's built to order. We essentially work with you to size your infrastructure, ensure that it's got the right amount of storage and type of storage, the right number and types of instances, and then we configure to order to meet your needs. An Outpost can be one rack. So I'm going to pause here before I press on and talk about a few customers who have adopted Outpost to meet their needs around local data processing and residency, and even see some benefits in performance by using this model. So the first customer I'd like to talk about is First Abu Dhabi Bank, which is the UAE's largest bank. And essentially, they wanted to use AWS, and they're using AWS for other use cases. But when they looked at how they could transform their user experience for their banking customers in the UAE, we hadn't announced an AWS region, and they really had specific regulations and requirements that they needed to keep data and processing within the UAE. So when they learned that we were releasing Outpost, they really dug in and decided this could be a great fit because essentially they could build modern cloud native applications using containers, using managed services, but be able to operate that and store and process data on premises. Another company is an iGaming company called Tipico. They're based in Germany and a large gaming operator worldwide. But as they were looking to expand into the US market, they had some very specific regulatory requirements, sovereignty requirements that each individual state that they were going to operate in imposed upon them, that the data and the processing for the platforms that were deployed in those states, the gaming platforms that were deployed in those states, essentially had to stay within those states. So we didn't have regions, obviously, in every US state. And so really they were able to take the application stack that they had deployed in AWS in Germany and other EMEA countries and deploy that on Outpost in these specific states and meet the requirements. So one of the first things to remember, though, when it comes to any form of cloud security and governance and sovereignty is it is a shared responsibility model. So essentially, there's a portion that is managed by Amazon Web Services around the foundational services and the global infrastructure, where we manage all the security elements, including code patching, physical security of our regions, and the personnel that work in there, and all the controls and encryption and capabilities that allow you, the end customer, to meet your requirements. But then you also have responsibility as well. So you have to configure and monitor and ultimately enforce the controls, things like access controls and policies. You're responsible for the data itself and the platform and application management. And ultimately, on top of the infrastructure and services that we deploy, you really own the operating system, the network, and the firewall configuration to allow all the connectivity. I mentioned that Outpost is like an extension of a region, but one of the key differences is that we're taking AWS infrastructure and installing it in your data center. So essentially, that does push some of the capabilities up into your sphere of responsibility as well, to where you have to provide physical security and access control for the data center where Outpost is installed. You have to assume responsibility for regional connectivity to the Outpost, environmental controls to ensure that the Outpost stays operating properly, and ultimately capacity management to make sure that you don't run out of capacity. But beyond that, it really does rest on the same shared security model that we've established for AWS regions. So now switching gears and talking a bit more about Outpost logical security, I mentioned Outpost is an AWS managed service. What this means is the best mental model to think of this is I mentioned Outpost uses the same physical infrastructure, the same Nitro security key environment that we use in an AWS region. So the mental model I present here is that consider Outpost to be like taking a piece of an AWS data center and stretching it all the way to your physical location where you want to deploy and keep your data and processing over a very long cable that's tied back to the region. Because it's a managed service, and because there are a lot of benefits to keeping the control plane in the region so that you're using the same pane of glass to monitor Outpost and your regional services, as well as getting the resiliency and scalability of having that control plane in a region, we have to have a service link between Outpost and an availability zone in a home AWS region that you choose. So that's a key part of configuring for an Outpost, is really being mindful of that service link. Outpost does need to be continuously connected to the region to operate properly. It can tolerate disruptions and outages on that service link and keep on operating. But ultimately, for proper operations, it does need to be a very reliable, very resilient connection between Outpost and a home AWS region. So essentially, as I mentioned, the control plane stays in the region. You install Outpost in your physical data center where you want it. And then we establish a VPN tunnel to anchor Outpost within a single AWS availability zone in that region. We use TCP UDP port 443, which is required, so we need to make sure your network is configured appropriately. And then each Outpost server in that Outpost system or Outpost racks essentially makes a service link connection back to the region. This helps with redundancy as well as individual management capabilities. The one thing to note is since a lot of you, to meet your security postures, don't want outside actors coming into your data center over a port, the service link is established outbound from the Outpost to the AWS region. So it originates from your premises into the AWS region, not the other way around. And there are two elements to this service link I'll dive deeper into. One is that there's a data plane where, with the appropriate controls, data could flow back and forth between Outpost and an AWS region and the management plane, which is where all the control and monitoring capabilities happen. And essentially, this is what goes over the management and control plane between the AWS region and the Outpost. So if you look at Outpost, because it's a managed service, it's sending telemetry back to the home AWS region so that we can monitor the health, the state, and hardware metrics. As part of that managed service, we want to make sure that everything's operating properly, and we use this telemetry data to do so. It also sends CloudWatch metrics back to the region so that you can have auditability of what happens on the outpost. And if you don't specify the right security controls, it can send RDS backups if RDS is running on Outpost and Snapshots back to the region, and local EBS Snapshots. But there are controls to put in place, which David will get more into, that permit that. On the flip side, there are data and information that flow from the region to the outpost. As I mentioned, the control plane resides in the region. So that means things like identity and access management is hosted in the region, and Outpost talks to the region to authenticate. The control plane for several managed services like EKS, ECS, our managed container services, and EMR, our managed analytics service, reside in the region. DNS and API calls reside in the region, as well as Amazon machine images for the compute on Outpost will flow from the region to Outpost. And then system management, when you control Outpost and perform system management from your AWS console, those will go from the AWS region to Outpost as well. The default method of operating Outpost, as I mentioned, being an extension of an AWS region, is that you're really taking an AWS VPC connection and extending that on premises where Outpost gets its own unique subnet. If you don't have regulatory requirements around residency or sovereignty, a lot of customers use this model to have access to scalable compute in an AWS region, or data mobility, or to be able to call AWS services in a region. But on the same token, if you are deploying for data residency use cases, you can keep VPCs contained within your Outpost so that data can't flow over the VPC between an AWS region and Outpost. And you don't have to worry about customer data exfiltrating back to the AWS region. So really, both models are equally appropriate. But for the purposes of this webcast, this is obviously the configuration that we want to drive. And ultimately, when you start to put that together, the control lives in the AWS region, and that control link can go over a WAN, over a private connection, or you can use AWS Direct Connect, and the limited metadata and control data flow between the region and Outpost. But then all of your customer data and processing can stay resident on the Outpost, running on services deployed in the Outpost like EC2, stored on Elastic Block Storage and Amazon S3 on Outpost, and then connecting into your local network through switching devices on the Outpost called the local gateway that allow you to hook Outpost into your on-premises existing user compute and storage environments. So I'm going to dive a bit deeper into a couple of key services that start to make this happen. The first is S3 on Outpost. If you're familiar with AWS, you know that Amazon S3 is a fundamental and elemental AWS core service that a lot of apps use for storage. And so a lot of apps are written to use that S3 object interface. We have S3 on Outpost, where you can provision S3 buckets on Outpost and store data locally, so that you get those same object API capabilities on Outpost. It's managed from the region and controlled from the region, but the data is ultimately stored within your data center on S3 on Outpost. So essentially, In this scenario, object data, object system, and user metadata and object tags are all kept on Outpost. The buckets are created and managed in the Outpost home region using that kind of region-based control plane model that I talked about. And telemetry from those storage buckets are available in the home region through Cloudwatch, but ultimately the data stays on Outpost. S3 on Outpost utilizes the same security and access control features as S3 in a region. So if you're used to securing S3 in an AWS region, same capabilities apply to Outpost. So essentially, there are a few things you need to be mindful of when you're setting up S3 on Outpost. The first is that you need to create a access point on Outpost. In the AWS region, you have the capability to use the legacy method of accessing S3 or using the newer capability called access points. But on Outpost, we only support access points. So essentially, you use either the AWS SDK or the console or the CLI to, once you create a bucket, to create access points for that. Once you create the access point, then you need to create an endpoint for the specific VPC that you've mapped to that outpost. And so once again, this is done from the region using the S3 API or SDK or CLI, where you're going to go ahead and create that endpoint, give the subnet ID, and then it will configure elastic network interfaces within the specified subnet for that bucket, and will also contain the resource name of that endpoint. So then once you've set that up, you can now start to use S3 on Outpost. And essentially what you're going to do, and this, I'm showing a put object here, but this equally applies to a get object. You're going to specify the key or the name of that object you want to put or get. And in your request, you're going to use the ARN of the access point as the bucket name. And then the request will get authenticated back to IAM in the AWS region to ensure that you do have the proper privileges to create or get or perform actions on that object. And then you will be able, once that's authenticated back to the region, to be able to access that object. So I'm going to wrap it up before turning it over to David to talk about another key capability that goes hand in hand with S3. One of the ways people protect their applications and data is to use EBS snapshots. And in this case, snapshots can be stored locally on S3 on Outpost. So essentially you can take snapshots, point-in-time images of your data, your boot volume, and your EBS-backed AMIs that you're using to deploy your applications and OSs, and store those on Outpost. You obviously do need S3 on Outpost to do this, and then essentially you can start to create point-in-time incremental snapshots using the same EBS snapshot APIs or CLIs that you would use in a region, and those stay in Outpost, so they don't go back to the AWS region. So these are some of the foundational comments. I'm now going to turn it over to David to do a deeper dive into the specifics of how you start to set up and enforce.
So I'm David Filiatro, and I'm going to start by talking to you about encryption on AWS Outposts. So on the physical security side, it starts with the Nitro security keys. Here, the key material is wrapped to this external key that's stored in a removable device and is leveraged as part of a trusted platform module. If the key is removed, any data on the server is cryptographically shredded per the NIST 888 standard. This is whole disk encryption. And the physical destruction is enabled by turning a screw on this key, and it physically destroys the chip that stores the key. These keys have a one-to-one relationship with the server, and they can't be replaced. Also, you can't remove a server from the Outpost rack without removing this key. It actually blocks you from removing the server. So also, I have a quick envelope encryption primer. So starting on the upper left here, you have the hardware software, which generates a symmetric data key. This data key, combined with the plain text data, is used to encrypt the data, and that encrypted data is then stored. Start now on the bottom row, take that same symmetric data key, and using the master key, encrypt that data key, and then that encrypted data key is what gets stored. Okay, the master key in this slide translates in Amazon world to the customer master key, and this customer master key lets you set policies so you can control what users and roles have access to the key and what they can do with the key. You can also set conditions like this key can only be used by these services or only by these VPCs. So it gives you lots of fine-grained control there. Now let's talk about how the keys get used. So with EBS, it is always enabled by default, and it actually can't be disabled. You do have control over what key gets used, what CMK gets used. Data is always encrypted inside the volume. All the data moving between the volumes and the instance is encrypted. Any snapshots created from those volumes are encrypted, and any volumes created from those snapshots are encrypted. We use the industry standard AES 256 algorithm using a unique key per volume. Your data key is stored on the disk with your encrypted data, but not before EBS encrypts that data key with the CMK. Your data will never appear on disk in plain text. If you'd like to know more about data keys, strongly recommend the AWS KMS Developer's Guide, which goes into great detail there. Now let's talk about S3 on Outpost encryption. All the data is encrypted in transit and in rest. In transit, we use the transport layer security, or otherwise known as TLS protocol. At rest, we use that same AS256 algorithm. And for keys, you have two choices. The default one is server-side encryption with Amazon S3 managed encryption keys, and we call this SSE-S3. And here, S3 encrypts each object with a unique key, and as an additional safeguard, it encrypts that key with the master key, and it rotates that master key regularly. Or the other option is the customer can supply the encryption key, and we call this SSE-C. Here, S3 does not store the encryption key you provide. Instead, it stores a randomly salted HMAC value of that encryption key so it can validate the future requests for it. This salted HMAC value cannot be used to derive the value of the encryption key or to decrypt the contents of the encrypted object. This means that if you lose the encryption key, you lose access to that object. So you need, when you're supplying the encryption keys, then you're responsibility for the safeguarding of those encryption keys. Okay. Now let's talk about how you can prevent actions from ever succeeding. These are preventative controls that we implement using service control policies and IAM policies. And for example, we're going to show you examples of how to prevent data from being copied from an outpost to a region. So there's two main types of policies I'm going to talk about. Identity-based policies. These are policies that you attach to users, groups, or roles. And these policies grant or limit permissions to a specific identity. The other type is organizational SCPs. These are AWS organizations' service control policies, and these define the maximum permissions that an account or organization or organizational unit can have. SCPs limit permissions that an identity-based policy or resource-based policy grant to entities, users, or roles within an account, but they do not grant permissions themselves. That can just be used to deny what people can use. So defining the maximum permissions. So let's see an example of this policy. So with EBS snapshots, you want to deny the ability for those snapshots to be stored in the region. So for this policy, the effect is deny. The action is EC2 create snapshots. So this is how you create a snapshot. The resource is the ARN of a snapshot. Now there's two condition keys here. The first condition key is this snapshot that is of an EBS volume, is the source of that volume, is that on an outpost or not? The second condition is basically a null, means if this condition key is not present, and that EC2 outpost ARN is only present if the destination is an outpost. So if it's not present, then that means it's going to the region, and we want to deny that. So if both of these conditions are true, it's on an outpost and it's going to a region, we want to deny. And that's what this policy does. So let's look at an example of the commands that you can use to test this. So this first one, the volume, in both examples is the same volume, and it has to be a volume that I've created on an outpost. The difference between these two commands is the first one that's actually allowed is specifying the destination of an outpost ARN, while the second one doesn't. If you don't specify the destination of an outpost ARN, that defaults to go into the region. And because that second clause, since it doesn't specify an outpost ARN, it's going to get denied. Both these, since the volume is an outpost, the first condition with the source was on an outpost, that's going to evaluate to true. But if you did do a snapshot on a EBS volume in the region, it would succeed because that first condition, is it on an outpost ARN, would be false. And so that policy wouldn't apply. Okay, now let's look at policy for S3. So again, the effect is deny. The action is S3 put object, and that same S3 put object is used for both in-region buckets and on outpost buckets. But in the resource here, notice that in the ARN, in the service field where you see S3, that's the service field, S3 just refers to in-region buckets. On outpost buckets, that service identifier would be S3-outposts. And since we're not denying S3-outposts, you can, this SCP or as an IAM policy would not deny going to outpost S3, it would just deny to in-region S3. So let's look at examples there. So on this first one that's allowed, notice that the bucket ARN, the service identifier is S3-outposts. And then you can see that it has the actual outpost ID along with the access point. The ones that are denied, the first bullet point under denied, notice how the service identifier is just S3, so it matches that policy on the previous slide. Then the second one is denied because it only specifies the bucket name, and by default, the bucket names without specifying access points are always in region, and that then translates to an ARN that is S3, not S3 on outposts, and so it gets denied. Okay, let's look at other examples. So let's deny instances to in-region subnets. So again, here the effect is deny. The action is run instances or creating EC2 create network interface API calls. Here the resource is a network interface, just has a single condition. That EC2 subnet condition key says what is the subnet that's applicable for this request. And here we're going to substitute in just outpost only subnets. So in this condition, it's just a single condition. The condition key is on EC2 subnet, and we're specifying an outpost only subnet, specifying the ARN for that. And if the ARN is not equal to that, so therefore it's an ARN that is of an in-region subnet, then this is going to be true. And so this deny policy would take effect. And I am using the syntax here from Terraform of dynamic substitution of a subnet ID. Some other API actions that you might want to deny are for copying data into the region. So for example, this first one, the action EC2 modify image attribute, you can use that to share images, and you want to probably prevent that. Second one, copy image and create image, and these other EC2 ones are all about the ability to store data into S3 in the region. So you want to block those. Right now, RDS, create DB snapshot, only goes to the region. That will change in the future. But for now, you would want to block that to prevent the data from going to the region. Same with Elasticache, its snapshots only go to the region today. And data sync can be used to configure replication of S3 on Outpost data to S3 in the region. So you'd want to block that. I'm going to do that for all resources. There's also API calls that can put data directly without storing it on the Outpost, but in a data residency scenario, you may want to deny putting any data into the region. So here's a list of actions. For example, DynamoDB put item. DynamoDB is not available on Outpost, so that can only put data into the region. EC2 create traffic mirror session, that would copy all your network traffic to the region. ES create, that's Elasticsearch. Since Elasticsearch is not available on Outpost, you probably want to block that. Same with Elastic File System, Storage Gateway, the Neptune DB, Glue, Data Pipeline, and these others. Those are all in-region services, so you probably want to block those. In fact, general security policy is if you're not using a service, you should go ahead and block the whole service with an SCP. Okay, and all resources and the effect of deny here. This is not an exhaustive list. It's just a sample list of the most storage-oriented APIs that we have. So now application logging. So by default, Outpost does not perform application level logging. We do have Cloudwatch Logs, which is used for logging. And if you enable the Cloudwatch agent, or you call the logs that put the log events API, that data is going to go to the region because Cloudwatch Logs is not stored on an Outpost. It's only stored in the region. In this case, if you are going to use Cloudwatch Logs, it's up to you to ensure that your application logs do not contain any residency impacting data. If you can't accept the risk that somebody might accidentally log data residency data to your application logs, you would need to find another logging solution and then block Cloudwatch Logs with the logs.put log events API in a deny policy so that data would not get to the region. Services that use Cloudwatch Logs that you might not originally think of are, for example, Systems Manager. If you're running EC2 instances with the SSM agent and the Cloudwatch Logs agent enabled, that would copy data to the Cloudwatch Logs in the region. Same with SSM's Send Manager command has an option for logging to Cloudwatch, and the Start session has a configuration where you can send data to Cloudwatch. Also, ECS and Docker have a AWS Logs driver that can go to Cloudwatch, which would put the data in the region. So you either know you want to block this or maybe conditionally do it for some roles but not others. So this is something that you need to think about. Other controls. So if you don't have in-region subnets, you can't create resources that are subnet based. So for example, RDS resources, if you want to really prevent an RDS instance from being in the region, don't have any in-region subnets. So block the ability to create those or tightly control who can create subnets. And if you already have any in-region subnets, delete them unless you know you need them. Now, sometimes you will need in-region subnets. In this case, as with all security practices, use NACLs and security groups to tightly control what components can talk to what other components. So you strictly control what they can communicate with. And if you do need VPC endpoints, you could have an IAM policy or SCP, which denies the run instance on the subnets with those VPC endpoints. Other design considerations for data residency. You may choose to store data outside of your Outpost in your data center. You can use your own SAN, or you can use one of our Outpost Service Ready partners that provide storage, like Infinidat, NetApp, Pure Storage, Zadara. So with on-premise backups, you may have requirements where you don't want to store your backups on the Outpost device itself, although you can, But if you have requirements where you need to store that outside the Outpost, but your data residency requirements eliminate you from being able to store your backups in the region, then you need a solution for your backups. You can use any application-specific mechanisms you have, such as dump files, or you can use OS agents that copy the data. And we have service-ready partners for this too, including Commvault, NetApp, and Veritas, that have all verified that their products work with Outposts. So with disaster recovery, you can do replication through the LGW, the local gateway, and you have options there. You can do application level, like with database native replication or Redis replication. You can use OS level, for example, Cloud and Door disaster recovery, and replicating through the LGW to another Outpost or to some other thing that you're using for your disaster recovery environment. Okay, over to you, John.
I'd like to wrap this up by recapping the AWS Outposts Data Residency model. David took you through several of the security and access controls that you need to be mindful of to use Outposts for data residency. So when you configure properly using those controls, your compute, processing, and data storage stay local on Outpost. All data is encrypted as it stays on Outpost, and all control data that goes back to the region is also encrypted. The control plane itself and the monitoring and the logging and telemetry for Outpost stay in the AWS region, but there's no AWS operator access to that data. It's entirely under your control, and you manage the Outpost that way. So when you put these two elements together, control plane and telemetry to the AWS region, local data processing and storage encrypted on the Outpost, encryption over the communication links between Outpost and the region, it generally meets security and governance requirements associated with residency. Ultimately, as we talked about earlier, it is a shared security model, and you, the customer, need to make the final determination that Outpost is going to meet your requirements.
So in conclusion, Outpost can be used to meet your data residency use cases. Use the policies discussed in this webinar as part of your data residency strategy. And if you'd like to see additional webinar content, either on KMS key policies or detective controls that are relevant to data residency or anything else, please let us know. I'm with Professional Services, and we can help customize solutions for you. Thank you for your time. And you can reach John Mallory at his email there, or myself. You see my email there. And now we have time for questions and answers. Thank you for your time.
Thank you.